So 14, which is e to the x, over the square root of 1 minus e to the 2x dx. So, hopefully you're thinking, when you see this, like, so you got a denominator, so u could be what's down there, but this also looks a little bit like an arc sine, because we got 1 minus something squared there. Okay? So, we could try a couple things here. Like, you could say, oh, I think u is going to be 1 minus e to the 2x, because that's what's inside the square root. Sometimes that works. But then du would be negative e to the 2x times 2. That's the derivative of that. Okay. Now I have an e to the x up there. I can put a negative 2 in there, but I don't have e to the 2x. I just have e to the x.
But I thought like if you derive u, you get
No. The derivative of 2x is negative 2 e to the 2x. But 1 minus that, okay? Like it should be ln of e there, but that's 1.
What if everyone just fails?
But either way, we cannot get... See how the du's here? Look, we can't get du to be up there. We don't have an e to the 2x. We just have e to the x. Okay? Which means that this is not the right substitution. The only way to get e to the 2x up there is for me to multiply by another e to the x here. That's going to make it e to the 2x. But if I multiply by e to the x in there, then I got to divide by e to the x down here. This would become the du. Does that make sense?
Yeah, but wouldn't that just be e to the x squared?
Up top, that's the same thing as e to the 2x. You add the exponents. Okay? But either way, look, like this isn't going to work out, because if we try this here, look, we're going to get integral this is e to the 2x up there times dx. So that's just du. Then we have 1 over the square root of 1 minus, just u, I mean, right? Square root of u. But then we got that e to the x left over on the bottom. Like this is still sitting there. And I can't get rid of that, and I can't switch it to u's. Like I'd have to solve this for e to the x, which is going to be a real pain in the butt. Okay? So this is not, that's how you know this isn't the right substitution. It didn't turn into an easy integral. Okay? So that's not right. So then you go back and you're like, okay, great. Let's try something else. So we take a look at this. That didn't work. And again, like I said, hopefully you got to recognize this looks a little bit like arc sine. I don't think that's the first thing you should think. But once the u sub doesn't work, then, well, you're like, maybe it's an arc sine, which means that this in the square root should be 1 minus u squared. Okay? And
so u is just negative e to the 2x.
No. Yo, e to the x squared, I feel like you're missing this rule here, is e to the 2x. They're equal to each other. Okay? So I need e to the 2x, which is this, to be u squared. But that's e to the x squared. So I need u to be e to the x. Because that's going to become 1 minus u squared, based off of this rule of algebra right here. And then du is e to the x dx, and oh my goodness, we have that sitting right here. There's my du. I don't have to do anything fancy. That's du. So this becomes the integral.
So it's not, the u isn't like 1 over e to the x?
No, u is e to the x, because then we're going to get the square root of 1 minus e to the 2x, which is the same thing as e to the x squared. So that becomes u squared. And we know a rule for that. That's just arc sine of u. But u is e to the x.